Welcome everyone. Today I'm presenting my Agentic AI project. It serves two purposes at once. It fulfills the requirements for the EN.705.625 at Johns Hopkins, and it lays the foundations for my doctoral research infrastructure. Those two goals are aligned, which is why this isn't just a class project. It's a system I will keep using long after this semester ends. So what is ScholAR²? It is a multi-agent research intelligence platform. At a high level, it watches a directory and ingests whatever appears: PDFs, code, notebooks, LaTeX, Markdown, Word documents, and more. Each document is routed through specialized agents, each handling a specific cognitive task: summaries, references, terminology, acronyms, code structure, and relationships across documents. The real bottleneck in academic research isn't reading, it is synthesis. You accumulate dozens, hundreds of papers, and each one demands the same effort. What is it about? What does it cite? Which terms matter? What does the code actually do? How does it connect to everything else? Single prompt extraction is shallow, manual synthesis doesn't scale, and raw RAG loses structure. So instead, the system decomposes the problem. Each task is handled by a specialized agent. A planner decides what runs and what runs in parallel. The validator checks outputs and retries only what didn't pass. The result is a system that grows with every document and reasons across the entire corpus. Now let's look at the architecture. I'll be honest with you, the diagram is dense. 11 agents, 3 message types, a parallel execution group, 2 query modes. Let me demystify it by following a single document as it travels through. It enters at the top and leaves as structured knowledge at the bottom. 6 stages organize the work. These aren't agents themselves. They're the high-level shape that maps onto the 11 specialized agents underneath. Detect. A monitor watches the file system. A new file appears. It classifies the type, computes a checksum, and decides whether we've seen this content before. Plan. An LLM-driven planner reads the document and produces an execution plan. Which branches to run for this document type, which to skip, what runs in parallel, what runs sequentially. Every document gets its own routing decision. Extract. This is where the work happens. 3 branches run concurrently. The first branch is a chain of 4 agents: summarizer, acronym, glossary, tagger, running sequentially because they share information through hint messages. The acronym agent, for example, posts its registry of extracted acronyms to the glossary agent as a skip list, preventing duplicate entries. 2 other branches, reference and code analyst, run in true parallel alongside the chain. Validate. A quality gate scores each agent's output. If something is weak, only that agent retries, with structured feedback. The pipeline doesn't restart. The strong outputs are kept. Index. A crosslinker discovers relationship across the entire corpus: semantic similarity, citations, contradictions. It uses vector retrieval to bound its work so its cost stays constant as the corpus grows. A vectorizer chunks and embeds the document for retrieval. Query. 2 modes: corpus query for analytics over the whole library, and RAG query for grounded answers from specific documents, plus a research assistant for topic analysis and text review. Detect, plan, extract, validate, index, query. Everything else on this diagram is just refinement of those 6 stages. Now let's see it run. ScholAR² ships with 2 interfaces: a browser-based GUI built on Fast API and React, and a console-based CLI for terminal-driven workflows. Both share the same agent pipeline underneath. A single entry point handles startup. It's a script called start.sh. It resolves the virtual environment and launches the right processes. So the usage is start.sh and then followed by a mode. And the mode can be either app or CLI or both. The app will launches the GUI, starts the Fast API backend and the React front end, then waits for and opens the browser. The CLI handles the console interface. There is no backend, no front end, just a REPL, and both will launch both interfaces at the same time. There's an additional optional parameter, which is the VNV path, which is the path to the Python virtual environment. By default, if we don't add this optional parameter, it will default to VNV, and it expects that the .vnv would be located in the root directory of the application. If not, for instance, if you have installed your virtual environment, say in your home directory under the name of .vnv313, you would add something like this to your command line. In this case, we're gonna bypass all this and we're gonna do the start with both. We're launching both interfaces and we're expecting the .vnv to be underneath ScholAR² in this case. And there we have it. This needs to be stay on all the time. But we're gonna minimize it. And these are the two interfaces. On the left side, the GUI, and on the right-hand side, the console-based interface. Most of the time, we're gonna 95% of the time, or even more, we're gonna use the GUI because it's more flexible. The console base is a bit for a power user. It has few more commands, mostly for managing the synchronization between the files and the databases. But most of the time, it's gonna be here, and this is where we're gonna demo the bulk of the application. Using ScholAR² is really simple. All we need to do is just ingest a document. There are three ways to ingest a document, either using the process document where we drag and drop the document, or we enable a watcher, which is basically monitors a particular directory, and every time there's a change in this directory, either because we copied the document or we downloaded or we written a new document, it automatically picks it up and processes it. Or, I'm going to stop it here, or using the sync where we have downloaded the document into the specific watch directory and document was not processed yet because the watcher was not on. This is basically you are downloading the document outside the control of the application, but then when the application launches the application, the sync will automatically discover that it has not been processed and will offer you a way to process it. Essentially, whether you're using sync, watch, or process, the result is exactly the same. 3 routes, same results. For the demo, first of all, let me show you the configuration file. There are 2 areas where you need to add your own configuration. These are in the environment, .environment, you have 3 keys that you need to install. And in the settings, the only one that matters is the watch directory. You can name it whatever you want. I've named it watched here. You can change this one. And that's all you need to do in order for the application to run. Typically, the watch directory is here. I'm going to show you what I got already all these PDFs in the watch directory. So the only difference between process and watched is that process, you can take a document from anywhere, and it does one extra step, is that it copies the document to the watch directory before processing it. So let's take this document, for instance, and drop it here, and you'll see automatically that the process of ingesting the document is starting. The first is the detection process, and then there's a hashing here where it tries to find if there is any other document similar to this one that has been already processed. And the idea is you can have the same document with different file names, and the application will detect that these two documents are the same and will not process the second document. Now the planner is kicking in, and then we can see here that in parallel we're gonna have this sequence, the crosslinker and the vectorizer and the validator. These are, some of them are in parallel, which is these two, and then the other are sequential. So the first step is it has created for this document a summary of the document with a key contribution, and it gives it 85% confidence. We're using one LLM to do the heavy lifting, and the other LLM to as a judge to validate what the first LLM has done. So we got the summary. We got now the acronyms. It detects all the acronyms and gives their what they stand for: API, application, programming interface, NLP, natural language processing. Then it processes all the references, 1 plus 34 in this case, which is basically the self-reference is the reference of the article itself, and the cited references are the references that it found within the article that reference other sources. Then there's a glossary. The difference between an acronym and glossary: an acronym just stands for what, a glossary gives you the whole definition. Then it gives tags, primary and secondary tags for the document. Finds the crosslink with other documents that are already in the corpus and gives it an attribute that, for instance, this document complements another document or extends or is similar to another document, and so on. Vector store gives a validation report about the coverages and the scoring, and here it gives you the processing time. The important thing to note here is that the word clock is 92 seconds, a minute and a half, but actually each agent worked, if you add the agent work, is about 137 seconds, which basically proves that the parallel aspect of the software is working nicely. We're shaving at least 40 seconds here. So with this, we have one document that has been ingested that took about a minute and a half, and then we have now the summary, acronym list, glossary list, reference list, tags, crosslinks, the whole shebang. And actually the document has been also chunked and vectorized and then can be queried. And let's take the same document and copy. Let's duplicate this one. And take the copy of it, which is basically, it has a different name, has copy, and see what happens if I throw it back again here. And it says automatically copy is already indexed. So it doesn't care about really the name of the file name. It computes the hash of the document and then finds if it's duplicate. So in this case, it has been detected. So now let's see what we have in our corpus. We can go to stats and we can scroll down, and this is the one that we just posted, ingested. We can click back on it, and then it's a different arrangement, but we have exactly the same information that we saw while ingesting. And we can click on any of these here to check the references, the acronym, the crosslinks. And you got the tag up here. So just a parallel here, the corpus stats, we have 36 documents, number of chunks, glossaries, acronyms, references, the 36 plus 36 of the self-references, and the 1481 are the references cited inside each of the document, how many crosslinks, and the tags. Just as a comparison, let's go to the console based, and then we're gonna type stats here, and we can see that we have 36, 1134, 1449, 39. So we have exactly the same thing, which just to make a parallel that we're querying the same corpus of knowledge. See how the sync works. So if you press on sync, we can see that we have absolutely no issues here. Let's now proceed and delete the file that we just added. Let's delete it. And let's refresh. So automatically we see that it's orphaned in the DB. So we have the entry in the DB, but the file does not exist. Let's take it out. Let's remove it. And then we're back in sync. So now that we have ingested the document, what can we do? We can query, we can research, and we can export. So with respect to the export, we can export item by item, glossary or acronyms, or the whole thing. So we're going to export the whole thing now and see what it gives us. And if you look at the output here, we have the acronym in LaTeX form, the glossary too, the references as bib. So we can just take them and place them in our research, our tags, and we have also the crosslinks as CSV. Now that the export is done, let's move on to the query. In the query intelligence panel, we have a couple of options. The first one is whether we want a corpus query versus a RAG query. The difference is that the corpus mode keeps the LLM inside the knowledge base, whereas the RAG mode uses the same chunks as context, but lets the LLM range beyond them. So both options use the LLM. The second option is that we have the top K here selection, which determines how many chunks the receiver returns. The default is 5, which is a proper middle ground. If you want more focus, select top 3. If you want more breadth, select top 10 or top 20. For the purpose of the demo, we're going to keep it at top 5. I'm going to paste a question. How do vision transformers handle spatial structure compared to CNN? And we're going to run it with the corpus mode and then later on with the RAG mode. So that's the answer of the corpus query mode. Based on the retrieved documents, I can provide a comprehensive comparison of how. And the focus is still on the chunks that are inside the corpus. And these are the 5 chunks because we have selected top 5. Let's run the same thing as a RAG query now. And here's the answer. The same chunks, but they are sent now as a context. And the answer is more general and beyond the corpus itself. Now that we understand how the query intelligence works, let's see what the research assistant has to offer. The difference between the query intelligence and the research assistant is that the former answers questions about the corpus, whereas the research assistant questions the corpus itself. In the same vein as the query intelligence, we have a corpus versus RAG option. For the purpose of the demo, I'm going to stick with the RAG. The corpus is exactly the same thing with different answers eventually. And the research assistant has a topic analysis and a text review. And the topic analysis works across the corpus. It surveys what the library knows about the subject, which papers touch it, how they frame it, where they agree and where they diverge. The unit is the theme and the output is a map. Whereas in the text review, it works inside a single document. It reads one paper closely, claims, evidence, structure, gaps. The unit is the page, the output is a critique. So for the topic analysis, I have this topic here that I have prepared for the demo. But a word of caution, the topic has to be of a certain length. If it's shorter than 15 words, you're prompted to continue if you want. Either you can proceed as is, but then it's going to be too short, or you can add some information here, or we can go back to the topic itself and type it over here. So let's analyze this topic. So the system ran the analysis and returned the structured report, not an answer, but a survey. The coverage comes first. The corpus is rated thin on this topic, strong on VIT foundation and representation learning, weak on the core efficient attention methods. Then we have the gaps that are enumerated and identified. We have the contradictions and consensus. Then we have followed by the annotated bibliography, which organizes the corpus by theme, foundational architecture, spatial aware attention, hierarchical processing, efficiency, etc. Each entry is a short critical note, not a summary. And then at the end, we have the synthesis that ties it together in a paragraph and points at what the corpus cannot answer. The user now knows what they have, what they are missing, and where the field disagrees. Let's switch now to the text review. And I have also prepared a small text here for the demo. And let's review this text. Where topic analysis surveys the corpus, text review audits a draft. The user submits a passage as we just did, and the system reads it against the library and returns three things. First, the supported claims, assertions in the text that the corpus backs each tied to the paper that backs it, like here for instance. Then we have in second place the contradicted claims where the corpus disagrees with the text and the disagreement is named. And finally, the suggested improvements, material the text overlooks with pointers to the corpus papers that would strengthen it, as shown here. In essence, topic analysis maps the field. Text review audits a draft. Topic analysis tells the user what is in the library, and text review tells the user what their writing is missing from it. I would like to end this presentation by showing some features of the command line interface. One thing that's important is the help, which gives you all the commands. Let's go with the stats. We can do stats, and then it will give us what's in the corpus. We can add stats with an index, and it gives me with all the documents. We're back with help. Check the acronyms, for instance, acronyms, and then we're gonna do a list. Gives me all the acronyms. Let's do the sync, status of the sync. So these are, so everything, we have 36 files on the disk and they're all healthy. Let's take this one, let's copy this one. And then let's see what we have. Yeah, let's see, show file name, show, and then the file name. So it gives me everything about the file. So that's the file here. The summary, the key contribution, the tags, primary and secondary, document counts, all the terms in the glossary, the acronyms, the self-reference, the cited reference, and the whole thing. We can do the query here also, query, and then we can say, is it a corpus or is it a RAG? Let's say RAG, and then the query is, what is self-attention, for instance. Attention. There you go. One thing that we can show also is the graph, which is the man-made graph of the application. Since it's written in LangGraph, it will show you the start, the monitor, the planner, the reference, the code analyst, and these work in parallel. This is sequential, and then they join here and then they continue. With this, we come to the end of the demo. Thank you for watching.